In this problem, we will solve the modal analysis of a thin rectangular plate. So our objective is to analyze the vibrational modes of the plate to determine its natural frequencies and mode shapes. So which helps us to understand its vibrational behavior. So the first step, we need to define the geometry by creating a thin rectangular plate with the dimensions of 20 meter in length, 5 meter in width and thickness of 0.1 meter. The second step involves meshing, where we will perform a polyhedron mesh. Next step, we will set the material properties using steel with a Young's modulus of 2.1e plus 11 and Poisson's ratio 0.29 and density 7850. In the fourth step, we will apply boundary conditions by selecting the bottom curves of the plate and fixing them in Z direction to prevent any movement in that direction. So the next step, we will configure the calculation settings, performing a modal frequency analysis and setting the frequency range from 30 to 300. Finally, we will check the results in the Fidesis viewer, all the 10 mode shapes, and observe how the rectangle deforms accordingly. So these are the 5 steps we need to perform, and here are some options we use throughout the process. And the next step, we will delve into the Fidesis software and perform analysis. So first step is to define the geometry. Open the command panel and go to manage geometry, manage volumes and select create volumes, then select brick, enter the dimensions, width of 20 meter, height of 5 meter and depth of 0.1 meter, and then click apply. And the next step is to mesh. Select manage mesh, then select manage volumes. Now to create the mesh, we'll select specify meshing schemes and select this volume. Then from the list, we'll select polyhedron and then click on mesh. The mesh size will set automatically after selecting the option polyhedron. The third step, we need to assign the material to the rectangle. So select the material management, so enter steel, select hook material and from general drag this density, set the Young's modulus to 2.1e plus 11 and Poisson's ratio to 0.29, then 7850, then click apply. Once the material is done, we need to create the block. So select this rectangle, then create the block. Now assign the material to this block, then click apply. Now we will apply boundary conditions. So we will fix displacement. So for that, select curve, then select the edges, so we will select all the bottom edges. Now we'll restrict in Z direction. Now click apply. So you can see here it will automatically take the degrees of freedom value to 0. Next step is to solve. Set the calculation parameters. Navigate to mode frequency analysis, general settings. Set the number of eigenmodes to 10. Select interval and set it to 30 to 300. Then click apply. Before calculating, save the file. Now click on start calculation and save the file. Now you can see that the calculation is finished successfully. Now to view the results, you have three options. You can simply press Ctrl E to quickly open the results, or go to the main menu, then select calculation and then open results. And the another option is to go to the comment panel and then select open last result and click. So this is the model. Now to see how the plate deforms at different natural frequencies, we will use tool called warp by vector. Now I'll set the scale range to around 127 and then click apply. So this allows us to visualize how the plate bends or vibrates. So now based on the selected mode, you will be able to see the deformed shape. So if I select mode 2, you can see it, and mode 7, how it is deforming. So I'll select all the modes. This is mode 1, 2, 3, 5, 8. So this is how it looks like.